Hi, today I'm going to talk about the metric system. You have probably been introduced to the metric system in your life at some point, but if you've grown up in America, you've never really used the metric system very much. And it feels really scary. It feels really completely foreign and alien to you. But I'm telling you, the metric system is so easy. And I'm going to give you a saying to help you remember it. I'm going to give you a way of organizing it to where you can remember it. And I'm going to show you how to use it. Okay, so let's get started. All right, here we are working on the metric system. Okay, so the first thing that I want to talk about is I have a saying, and I was taught this saying in college. So don't judge me for it. I did not make this up, but it is a saying to help you remember your metric system prefixes. Okay, and the saying is extra puffy, tall green, musty kangaroo huts dry up during cold months, make nice angel pillows for Adam. And I know it's a crazy sentence, but it's fairly easy to memorize. And what it is the first letter of each of these is the first letter of your prefix. Okay, so I have them all written along the side here. Okay, so you can see them. So in order for us to be able to use this easily, I'm actually going to have to switch it to where I'm going the other way. So it's going to make it a little bit smaller for you. Okay. But I am going to make it extra big right there so you can see it. Okay. Okay. So what you want to remember is the up in your saying is your central unit. Okay. And so that's the unit that they all have in common. Okay. So I can talk about grams and I can compare it to kilograms, milligrams, micrograms, whatever I want to compare it to. But the thing without the prefix, the gram, that's your central unit. Okay. And it can be anything: grams, liters, meters, seconds, joules, calories. It can be anything that we're talking about. Okay. The up in your saying is your central unit. Okay. So what I want you to recognize is everything above the up. Oops. Everything above the up is capital letters, uppercase letters. Okay. Except for the kilo. Kilo, for some reason, we use lowercase k. I think it's because in chemistry, an uppercase k means other things. So we use a lowercase k for kilo. Okay. But everything down below the up, you'll notice, are lowercase letters. Okay. Except that angstrom right there. The angstrom is actually an uppercase A instead of a lowercase a. Okay. So one of the things I want you to recognize about this is looking at these numbers here. We start at 18 and we drop by threes until we get to 3. And then we drop by ones for this last 3. Okay. Now what I want you to notice is the bottom, except for the angstroms. Except for the angstroms here. Okay. The bottom is exactly the same, by threes. You go up by 1 until you get to 3, and then up by threes. Okay, so it is a mirror image of itself. Okay, except for that angstrom right there. Except for the angstrom, this is a mirror image of itself. Okay, where we have the 18, 15, 12, 9, 6, 3, 2, 1, 1, 2, 3, 6, 9, 12, 15, 18. And then you have the angstrom, the 10 in the middle of there. Okay, so many of your instructors are not going to make you memorize angstroms, but I put it in there because some instructors do make you memorize it. Okay, so this is an easy way to go. Okay, so when you get to your exam or to your test or to whatever you're using this for, if you can't have it in front of you, then you just say in your head and just write the first letter: extra tall. Oh, extra puffy. See, I forgot my saying already. Extra puffy, tall, green, musty, kangaroo huts, dry up during cold, well, I didn't leave myself enough room there, months, make, but remember that make is a micro, okay? So remember this make, because milli took the M. Make is actually the mu. It's the Greek letter M. Make nice pillows. Oh, angel pillows. Angel pillows for Adam. Okay, and you know that this one, your exponent is 18. Go down by threes. 12, 9, 6, 3, until you get to 3. And then you go to 1. That's your central unit. Mirror image. 1, 2, 3, 6, 9. We have that 10 in the middle there. 12, 15, 18. Okay? So that's a way to memorize, just to remember a saying, or you can make up your own saying, whatever you want to do. Just some kind of a saying to remember those. And so many of them you're not going to ever need to use. Like you'll probably never use peta. You'll probably never use hecta. Likely never use deca. But they're in there because it makes it easy to memorize. It makes it a mirror image of itself. Okay? So I feel like that's the easiest way to do it. Okay? And so now I am going to switch over and we're actually going to do some practice with this. Okay, one of the things I forgot to mention when I was talking about this is everything that is above here, where I was talking about with the uppercase prefixes, these are larger than your central unit. Okay, and these down here are smaller than the central unit. Okay, so what that means is we're always going to put the 1, and I'm going to write this up here because we're going to be using it in a minute. So we're always going to put the 1 with the larger unit. Okay, so the 1 is always going to go with the larger unit. Okay, so if you're using these prefixes here, if it's any of these prefixes, these get the 1, and this gets the times 10 number, whatever that exponent is. Okay, if you're working down here, these get the 1, and these get that times 10 number. Okay, because when we're looking down here in one of these, we have a lot of these because they're smaller. Whereas when we're looking up here in one of these, we have a lot of these because they're smaller. Okay, so the 1 goes with the thing that is higher on the list. Okay, so let me write that here with the thing that is the larger unit, which means whatever is higher on the list. Okay, okay, so let me erase that real quick. Give us some space to work here. Okay, so now what if I ask you, and actually I'm going to flip my screen this way so we can see it a little bit better. Okay, so what if I were to ask you, how many milligrams equals 45 grams? Okay, and I use the railroad track method. Okay, so some instructors might actually do this by using parentheses. So they would say 45 grams, and then here they would have this, okay? So what I want you to recognize is this right here is just the times and the parentheses, okay? So to save myself time from having to write the parentheses and that multiplication symbol, I just use what we call the railroad tracks. And many of your instructors are going to use that same thing because it's just easier, okay? Okay, so again, I was saying how many milligrams are in 45 grams. Okay, so we go to our little list here and we say, okay, I'm looking for milli. Okay, milli is right here. So milli is 1 times 10 to the 3. Okay, and on the list, grams is what we're looking for. Grams is higher on the list, so grams gets the 1. Okay, so here we know we're going to put grams on the bottom to cancel, because it has to be top and bottom to cancel units. It gets the 1, and the milligrams gets the times 10 number, the 1 times 10 to the 3. So I have 1 times 10 to the 3 milligrams for every gram. Those grams cancel. And now you're just going to say 45 times 1 times 10 to the 3, which is going to move your decimal 3 places to the right. So you're going to get 45,000 milligrams. Okay. What if I were saying how many kilograms equals 45 grams? Okay. So again, we're looking at grams. Okay. So grams is our central unit. But this time we're looking at kilo. Okay, so see, kilo is also 1 times 10 to the 3. But in this case, kilo is higher on the list. So kilo gets the 1. We know we want grams on the bottom to cancel, kilograms on the top. Kilo's higher on the list, so it gets the 1. And the grams gets the 1 times 10 to the 3. Okay? Okay, so you see that it just depends on which one's higher on the list, which one gets the 1, and which one gets the prefix. I mean the exponent, okay? So that's the big thing you want to remember is the one higher on the list gets the 1, the one lower on the list gets the exponent number, okay? And if we did this math, we're going to move the decimal 3 places to the left, and you would get 0.045 kilograms, okay? Okay, so let's do a couple more. Okay, so what if I say, get rid of all of that there, give us some space to write. Okay. So what if I now say, how many megaliters equals 2 liters? Okay. So we are looking at mega, and you probably guessed, mega is probably going to be higher on the list because mega is pretty huge. Okay, so mega's up here. Okay, and our liters is down here. Okay, so mega is larger. We know we want liters on the bottom to cancel, megaliters on the top. Mega is higher on the list, so it gets the 1, and the liters gets that 1 times 10 to the 6. Okay, and that's going to give us 2 times 10 to the negative 6 liters, or 0.0000002 liters. Okay. Okay, what if I said how many picoseconds in 93 seconds? Okay. So we're looking at pico. Okay. And we're looking at seconds. So seconds is our central unit. And pico is not up top. So pico must be down here at the bottom. Okay, so our pico is right here under pillows. Okay, so pico. Okay, so our seconds is higher on the list, so our seconds gets the 1. Okay, so we know we want seconds on the bottom to cancel, picoseconds on the top. 1 second, because it's higher on the list, is 1 times 10 to the 12 picoseconds. Okay, and this is going to be a huge number to try to write in regular notation. So basically, you're going to be putting 12 zeros behind that. 5, 6, 7, 8, 9, 10, 11, 12. Okay. Or, oh, I don't know where I got that 2 from. That should be a 3. Okay, you can put this into scientific notation, which I have another video on scientific notation if you need a reminder of how to do that. But this is going to be, I'm going to move my decimal if it were right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so, sorry, my phone's ringing. Okay, so times 10 to the positive 13, because this number is larger than 1, it gets a positive exponent. Okay, if this number were 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 6, 7, 10. If this number were this would be 9.3 times 10 to the negative 13. Okay, if the number is smaller than 1, it gets a negative exponent. Okay? Okay, so the general rule is, okay, we generally say 4 zeros or more go to scientific notation. Because zeros are easy to lose. It's really easy to lose a 0 when you're putting it into your calculator. So the more zeros you have, the more likely you are to make a mistake. Okay? So 3 zeros or less, go ahead and just put it as a number. But 4 zeros or more, put it into scientific notation. It's just going to be easier for your teacher to read. It's going to be easier for you to put it into your calculator. Okay? All right. So let's do a couple of 2-step ones. Okay? So what if you're not just going to a central unit? Okay, so what if I were saying, let me get all of the rest of this erased, give us some space here. Okay, so what if I said, how many kilograms equals 29 gigagrams? Okay. So now I'm comparing two things with prefixes. Okay. But our relationships are always to that central unit without the prefix. Okay, so unless you are really, really good with exponents and adding and subtracting exponents and figuring out what the exponents would be with that, your best bet is to go to your central unit and then back again. Okay, so we're going to go from kilograms down to grams. And then from grams, we're going to go back up to, or sorry, we're starting at gigagrams. My bad. My bad. So we're going to go from gigagrams down to grams, and then from grams back up to kilograms. I went too far. Back up to our kilograms. Okay. So first we need to get to grams. When you have two prefixes, you have to get to that central unit first. Okay. So first I know I want to cancel giga. Okay. So giga here, and we're looking at giga to grams. Giga is higher on the list, so it gets the 1. We know we want giga on the bottom to cancel. It gets the 1, so our grams gets the 1 times 10 to the 9. Okay, so our gigagrams cancel. Now we're at grams and we're going to kilograms. Okay, so now we're coming back up again. Okay, kilo is higher on the list, so kilo is going to get the 1 in this case. So we know we want grams on the bottom to cancel. kilograms on the top. Kilo gets the 1, and the grams gets that 1 times 10 to the 3. Okay, our grams cancel, and now we can just do that math. Okay, and if you do that math, you should get, here, I'm going to double check on my calculator. I'm pretty sure we're going to have 2, 3, 4, 5, 6. Pretty sure we're going to have 6 zeros back there. But let me just double check. Yep. Okay. And if you were to go in scientific notation, put your decimal right behind the first real number. Okay. And you're going to move your decimal. 2, 3, 4, 5, 6, 7. And it's a positive 7 because this number is larger than 1. So it's a positive 7, not a negative 7. Okay. So let's try another one. What if I say, how many deciliters? Well, let's use meters. We haven't used meters yet. How many decimeters are in 6.0 terameters? Okay. Okay, so let's erase all of this mess that I've made here. Okay, so again, what I want you to notice is they both have a prefix. Okay, if they both have a prefix, it is a two-step problem because you have to go to your central unit first. Okay, so our first step, we're at tera, and we want to go to meters. Okay, so up here, here's our tera. Okay, it's above meters, so it gets the 1. Terameter on the bottom to cancel, and the meters gets the 1 times 10 to the 12. Okay, now we're at meters, and we want to go to decimeters. Okay, so now we're at meters, and we want to go to decimeters. We know we want meters on the bottom to cancel, and meters is above decimeters, so meters gets the 1, and decimeters gets the 1 times 10 to the 1. Meters cancel, and you're left at decimeters. And this, if you do the math, is going to give you 6.0 times 10 to the 13. Okay, and that's going to be decimeters. Okay, so I have some practice sheets on this. If you just contact me, schedule an appointment, we can go through the metric system, and I can work on some of the practice sheets and send you the practice sheets for this. So that's the general concept of the metric system, okay? So the big thing is memorizing a saying, whether it be my saying or you want to make your own saying up. Remember, your first letters in the words are your prefixes. So that's E, P, T, G, M. This is a lowercase k, H, D. This one is a lowercase d, C, lowercase m, mu, the Greek M, N, A, uppercase, P, F, A. Okay? And then remembering that your exponents start at 18 and go down by 3. So 18, 15, 12, 9, 6, 3, until you get to 3. Once you get to 3, you go down by 1, 2, 1, and now it's a mirror image. 1, 2, 3, 6, 9, but there's that weird 10 right in the middle there. 12, 15, 18. Okay? Okay, so that is a way to memorize your metric system, is how to use the metric system. And I think that's about all I have to say about that. Have a great day.